Okay, what we're going to do is we're going to take a look at the step potential, but we're going to get an opportunity to feel it.
That's okay.
Trust me. I work for the government.
Trust nobody.
I work for the government. Trust me.
Trust nobody.
Can you show me how that
Federal
spark
servant.
plug works?
Huh?
Can you show me how that spark plug works again?
Yeah, I'll show you that. Let me demonstrate that spark plug. Very good. All right, now what I'm going to do is I'm going to put these two plates in here, and I'm going to take and hook 110 volts between the two plates. Now the idea, what we can do here is simulate. This could be a bathtub, it could be a basement with water in it, it could be the step potential out there and, you know, what is going on here? Okay, there it is. Or this could be the dirt with a step potential. Now there's two things that I'd like us to learn from this. The first thing is we are going to be able to, for those who want to come up here, if you put your fingers in this way, all you're going to feel is water. Because the step potential is going to be, let's say, east to west. So if you put your finger in this way, you're not going to feel anything but the water. Now, see, we could learn something from this. As an example, if you jumped out of your car, you had to get out of your car. The wires leaping and all that sort of stuff, and you jump, and you start walking in this direction, and you start feeling the step potentials, what can we do? Do a 90-degree turn and walk in this direction, and you'll walk out of it. That's one thing I'd like us to learn. Yes?
When you feel the step potential, are you going to start feeling electrical shock, or when are you going to start to feel?
Well, we're going to simulate that with our fingers up here.
Okay.
That's why I want you to feel it. Now, when you come up here, I want one hand back here. So we're never going to have two hands up here. You'll stand on the mat. We got a class 4 mat down here, which is good for 40,000 volts. Now, the other thing that I'd like you to kind of catch a vision of, an appreciation of, and that is this. The water, when you rotate your fingers, you're going to feel 1 milliamp. However, this water is incapable of lighting a 100-watt light bulb. It will not light the light bulb. Now, when the National Electrical Code says concrete's a conductor, they're not talking about it being a conductor for a light bulb or a motor. It won't light a light bulb. It won't light or run a motor. But by golly, if we're standing on that concrete in our bare feet, it's going to conduct like this water. It'll conduct a few milliamps. That's all it takes to kill us. Now I'm going to hook the hot wire onto this plate, so this will represent our positive potential, our B plus or whatever. The neutral now is going to represent all of our grounded surfaces. That'll represent our I-beams. That'll represent the rafters. That'll represent the neutral conductor. And I have this going through a ground fault circuit interrupter, which we have checked. So it's working.
Wait a minute, who checked it?
I did. In fact, we checked it, right?
That's right.
So I have witnesses here. And I'm just going to, I want to take and run this thing so it doesn't pull off. And we'll take and put this right here. All right, now, I've got, well, we might have potential on there. How do I figure? You notice now it's lighting this up. What was the voltage for this AC sensor? 90 volts. So if I've got 90 volts out to here, I've got 90 volts over to here. If I take and put my meter on here, you'll be able to see the 110 volts. Maybe you can see it. I don't know if you can see those little red lights or not. Now, can you see them over there? Now I'll flip it back over your way in just a moment. When I go down into the water, you can see my voltage drop. Can you see that? All right, now, think of this as just a wire wound resistor. And I'm just sliding down the resistor. That's all it is. It's just a variable resistor. Rather than using some other material, I happen to be using water. Now, if I go in here in the water, and you can just see it go down to 0, you can kind of see the step potential there. I'll put the light in here, and first off, we'll make sure it's working by going metal to metal. Try to go metal to metal here. Now, when I go in the water is such a lousy conductor, it will not light the light. I can put one wire on the metal plate, and it will not light until I actually touch the plate. Well, it's just very, very close to the plate there. And yet, if I come up here and put my 2 fingers in this way, all I'm feeling is the cold water. Now, I can rotate around, and remember, I don't have much feeling in this hand. But you'll find out as you come out here, you probably won't feel anything. As you start coming in, you'll get into where you begin to feel something. The deeper you go, the more intense it'll be. The further back will be, the less intense it'll be. Now, back in 1980, I had a class of maintenance supervisors from the U.S. Post Office. And we had, I'm guessing again, 45, 43, 44 students. We had one young lady in that class, out of the total class, I do remember her name was Kathy. We had our chairs lined up where she just happened to be the last person as we went around the room. She was a young lady, I'm guessing 23, 24, 25 maybe, 100 pounds maximum, 5'4". She was out of the Lexington, Kentucky office. And the guys would come up here and they'd put their fingers in here and they'd rotate around till they felt the milliamp, and then they'd go sit down. Well, Kathy came up being the last one, and she took and rotated her fingers out all the way and went down in there. And I mean, I was impressed. And when she pulled her hand out, I thought she was done. She looked at me and says, "I'm not done." I said, "Oh, sorry." No. And then she takes her 3 hands and she runs down in there. I said, "Kathy, what are you doing?" She said, "I'm feeling the parallel circuit." "Oh, okay, but don't use up all my electrons. I don't want to run out. Need some for my next class." Now, she then began to put all 4 fingers in there, and she ran her hand clear down. Ooh, man, I got that sucker. Man, I must have a cut on that finger, I'll tell you. 'Cause I felt that one. She runs all 4 of her fingers and her hand down to the bottom of that tank and laid it on the bottom. Now, I had never seen anything like that up until that time. It's impressive. I said, "You done now, Kathy?" "Yeah, I'm done." So she went and sat down. Well, at 4 o'clock that night, I had to find out, what Kathy felt. I couldn't, I'd never seen anything like that before. So I closed the classroom door, and I'm telling you, I started putting my hand down in there like she was doing. And, I'm really feeling that on that little thumb. I must have a cut on this little finger. If you have a cut, you'll feel it, because remember, we're no longer got the 1,000 ohms. You're right down to the nerves. So that's why I'm feeling on the little finger. But I took and ran my hand down there, and I'm telling you, as I got down 1 or 2 inches in that water, my hand started going into contraction. I mean, I couldn't stop it. The muscle started going into contraction. And I kept forcing it, and when it got up to my wrist, the pain was unbearable. I mean, I couldn't hardly stand it, and I kept forcing, and when I got down towards the bottom, my hand started involuntarily going at 60 cycles. Now, I tell you, she came up here and laid her hand down there like it was unplugged. I mean, it didn't bother her a bit. I have seen since that time, maybe a handful, maybe a dozen at the most, people that have been able to do it. You want to come on up here? Now, put one hand behind. Now, first off, get on the mat and just put 1 finger in the water. Now, just hold it in there a minute. And all you're going to feel, now notice how conductive our body is. Can you see that? Now, this is voltage. This is not picking up current. This is a voltage sensor. So you can kind of see how conductive our body is. Now, pull your hand out and put the two fingers in this way. Don't rotate them. Just put them in. Do you feel anything but the water? All right. Now, very slowly rotate. There it is. Now, that's fine. That's good enough. All I want you to do is kind of get a flavor of what's going on. Look how vulnerable we are to electricity, and it won't light a 100-watt light bulb. What do we call it? Conductor or non-conductor? You know, it's a non-conductor almost to that light bulb, and yet it's a conductor to us. You're going to graduate with honors there, young man. Come on, why don't you try it?
I'm not dead.
Come on up there and just try it. I'm going to zoom in with my camera a little bit here. Now see if you can go a little bit deeper and then, go up towards the plates and
Yeah, I can feel it.
you can feel it pretty well.
Yep.
Can you go down any further?
Oh yeah. Yeah, it's sooner when you're down deeper.